Okay, so I handed your test back this week, being Success Week. We are supposed to spend the week reviewing, right? Plus your project presentations, which you whined enough to get me to move it to the second half of the week. So projects are due Wednesday. With every group should plan on presenting on Wednesday. If we have to go into Friday, then we will. I'm not going to limit your time on the presentation, but we'll play it by ear. Okay? Any questions about the final or logistics-wise? What's going to happen to you in the next week and a half? Corey?
How many points is the final?
The final is worth 20% of your grade, just like each of the exams and your homework / everything else. Right?
So it's no more than the other test?
It's no more than the other test. Right? So, but it does have, since it is a comprehensive final, it has yeah, but it also gives you the opportunity to show that you went back and learned some of the things that you didn't get right the first time. So it can improve your grade that way. You guys, what time are you guys scheduled for? Have you looked it up?
Wednesday
at 1:30.
Wednesday at 1:30. Okay. I'll make the same offer to you that I make to all of my 140 classes, and that you can come to any one of my 4 final sessions. If Wednesday's not a great day because you got another final that morning or whatever, I don't really care the reason, but you're allowed. But the problem is this semester, 3 of my 4 are on Wednesday.
The other one earlier or later?
I got them all on Wednesday. I got a 9 a.m. Wednesday, I got a 1:30 with you guys, and then I have my evening, or my online class for MA343 will be that evening from 5 to 8:30. So.
They said you had 4 though.
I do. Then the next one's on Thursday.
Oh.
What time on Thursday?
Well, I don't know why you need that. I think it's 1:30 Thursday.
Oh, that won't work. Yeah, that's what kind of thing.
I'm almost certain of that. It's in my syllabus, which I could pull up here real quick. But email me if you're interested in moving to Thursday. So if you want to switch times to one of the other times, then let me know that. Otherwise, I don't need to hear from you. But I'm trying to keep track how many people are coming to each, so I know if I got enough chairs or not. But it's never been an issue. I don't expect it to be an issue this time. Okay? All right. Well, I just handed back your 3rd exam, so I figure we'll start with that one by way of review. We'll go through this exam in a fair amount of detail, as much as you guys want to see, and then we'll go to exam 1 and go through as much as we can of that. We won't get probably very far into that today. Then Wednesday we'll do your presentations, and then on Friday we'll do whatever's left of 1 plus 2. All right? So, you have it, you're looking at it. Tell me which ones you want to take a look at. Actually, I can pull it up outside of this thing, I think. Might be helpful. Okay, the first question. U.S. agency for blah, blah, blah provides large quantities of wheat-soy blend for development programs. One study collected data on the vitamin C content of 27 bags of this soy blend at the factory, and then 5 months later in Haiti. All right? So that sentence tells you we've got 2 measurements on the same bag, right? When it was first made in the factory, they test the contents. then they ship it to Haiti, store it for 5 months, then they test it again. The distribution of vitamin C content is somewhat normal when the bags were freshly made, but this is not expected to hold after 5 months of storing. What testing procedure? So we've got paired data that we can't trust normality, and our sample size is less than 30. So we need a non-parametric test, but which one? Signed rank test. So that's, and I didn't take off if you didn't put Wilcoxon's name, but it is due to Wilcoxon. I bet I can't write on that. Doing this first.
Just click one.
Oh, I see. It's giving me two choices. Now I'll go back to that. That. Now I should be able to write.
You have to change to the pen.
Ah, thanks. Okay, so this is the Wilcoxon signed rank test. Okay. I didn't take off, but I might have X'd it out. There were a few people that wrote Wilcoxon signed rank sum test. And the word sum is technically not in the name of this one. It's in the other one. And that's how, out in the industry, that's how you hear them referred to. Oh, do a rank sum test. And that, oh, that's the Wilcoxon rank. Or do a signed rank test. Okay? What about the next one? Do you need to see that one, or? Let's see, I gotta do this, and then can I scroll? Yeah. Oh, the words don't come along, but. Any questions about this? This is the logistic regression question. It's actually turned out to be the only one I had on the whole test. I typically have more, but I think I told you I had shortened the exam because when I tried it myself, it took too long. So I took out the other logistic regression, which just had SAS output. So what about the first two parts of this? Proportion of high-tech companies, what are the odds? Then proportion of non-high-tech companies offer stock options, and what are the odds? So the proportions are basically conditional probabilities. The proportion is the number of high-tech companies out of that offer stock options out of the total number of high-tech companies. So there's 91 total, and it says 73 of them offer stock options. Right? So now how do you convert to odds?
Probability.
Yeah, 1 minus probability.
Probability over 1 minus probability. And what you'll find is that the 91s cancel. Right? If I leave it as fractions, and I put 73 over 91 on the top, over 1 minus 73 over 91. You end up, the 91s will cancel, and you end up with 91 minus 73 on the bottom. So basically, number of successes divided by number of failures. Right? So that's 73 over 91 minus 73 is 18. And you can have over 91 on both of those. You get the same thing. So that's 4.055. Is it okay for odds to be bigger than 1?
Yeah.
Sure. Right. Basically, you're 4 times as likely to offer stock options as to not offer stock options if you're a high-tech company. So similar thing for 3. Proportion is 75 out of 109, and then the odds are 75 over 34, which is 109 minus 75, which is 2.205. 2.059. So then, now we get into building the model. If we define an indicator variable x for high-tech companies as yes is a 1 and no is a 0, write out the model using Greek symbols. So that's log odds that y, that's not how you spell odds, y equals 1. And I say y equals 1, it's not, we defined x to be 0, 1, but y similar. A 1 is a yes, right? So yes, we offer stock options. So this should be OBBS. So log odds is equal to an intercept plus a slope times this x. That's all I needed on that. But then number 5 makes you now compute parameter estimates for those. Right? So think about the variable x being a 1 or a 0. When it's a 0, this term drops out. So the log odds of offering stock options is your estimate of the intercept. Right? So b sub 0 is log odds given x equals 0, which is a non-high-tech, so we'll say non-HT, non-high-tech. So log odds, and I'm abbreviating here, odds of y equal 1, given non-high-tech company. So this is the odds of non-high-tech, so I need the log of that number. So log of 2.2059, and that'll be B0. And that's 0.79113 if I go out to 5 places. And then if I plug a 1 in there, then the log odds for high-tech companies is B0 plus B1. I'm using B's, not betas, because I'm plugging in sample data. Right? So if the log odds given high tech is equal to the log of 4.055, that's equal to B0 plus B1. So that's just a number. B0 is now just a number. So move it to that side. Solve for B1. So B1 is equal to 0.60896. Right. So then you just plug those numbers in here and you have your model. Any questions on that? Okay, find the odds ratio. You have 2 ways you could do that. The easy way and the other easy way. What'd you say? Right, so this B1 you have as 0.6086, so OR for odds ratio equals E to the B1 power. And if you take E to the 0.60896 power, you get 1.8385. But you've also computed the odds up here. So take the ratio of the odds. So the odds ratio, and it says high-tech companies in the denominator. I'm sorry, in the numerator, right? So it'll be on top, this one will be on bottom. So 4.055 divided by 2.2059, you should get that same number. Okay, then let's see. I've had to Has everybody got what they want, what I wrote here? I'll clear all that, and then scroll up. So I give you the standard error of B1, and now I'm asking for a confidence interval, first on beta 1, and then transform that to give me a confidence interval on the odds ratio. So there was a few people that missed this, that transformed the variable. To get a confidence interval on beta 1, what's all you need to do?
Take the parameter estimate plus or minus your critical value times the standard error.
Okay? So the parameter estimate of beta 1 is B1 plus or minus 1.96, since this is a normal based logistic regression, everything is normal based. Somebody, I don't remember who, but used a T critical value there instead of a, that was you? Okay. And I think it's only, that you're the only one that did that, but that minor point's off, but it isn't T, it's Z. Right? Then that's times this standard error, 0.3347. So that was fairly easy. 0.60896 was this B1. Doing that, you get your interval. I'll just say it rather than take the time to write it. You should get negative, for the lower bound, negative 0.047, rounding to 3 places. Then the upper bound is 1.265. Okay? Now, transform the interval, so what do you do then?
Exponentiate.
You just exponentiate the endpoints of that interval. So the interval here is e to the negative 0.047 as a lower bound, and then e to the positive 1.265 for the upper bound. There were several of you that took the odds ratio, which is good, instead of the B1, took the odds ratio, but then added and subtracted this same thing. Right? But for a confidence interval on odds ratio, you first get the confidence interval in the log scale, and then just anti-log that. Right? So this gives you 0.95, I'll go to 3 places, 954, and upper bound 3.543. What do you conclude about statistical significance? It includes 1. Now it barely includes 1. 1 is really near one of the endpoints. So the p-value would probably be something like 0.09 or 0.10 or something kind of small, but not down to 0.05. So not statistically significant. Not sig, I'll abbreviate, since 1 is in the interval. And 1, remember 1 is the null value. That's, I messed up my 1. By null value, I mean it's the value that you would expect to get if the null were true. Okay? So there's the logistic regression problem. Oops. Let's do that. Number 8, what parametric test corresponds to the Wilcoxon rank sum test? I think most people got this. 2 sample t-test. This one, there was quite a few that missed this. This is kind of tricky. We talked about it, it's in the book, but if most people, if out on the street, well, that's not true. Most people out on the street, the Wilcoxon who? What? But most people that have dealt with statistical tests before if you say, hey, what does the Wilcoxon rank sum test, what does it test? They'll say, oh, it tests to see if the medians are the same. But technically, that is only true if you can assume that the two samples have the same distribution, or come from the same distribution. Right? Then you're testing that the two groups have the same median.
My only question is that you do say that the two distributions have the same shape,
Right.
and for the Wilcoxon rank sum test, and it's talking about the null hypothesis, that if it has the same distribution, you assume that the groups have the same mean, and that's one. And if it's not, then you test for the medians. If you reject the null hypothesis, but the null hypothesis with the same distribution is that they have the same mean.
I don't think so. I think it's the two groups.
Well-
The null distribution, if they have the same shape of distribution, then the two groups have the same median. That's the assumption of the
I
test.
think I
That's the
looked-
null hypothesis.
I
of
think
the
I
test.
looked in the book and it had two alternatives. It can either be this, if the same distribution, or it's this, that's not the same.
Well, it does have two, you're right. But if you can't assume they have the same shape, then this is all you're testing. They have the same distribution versus not have the
But it
same.
says it can be assumed that the distribution has the
Right,
same.
and so that's what lets you go to this version, that they have the same median. I don't think mean's ever in there.
In order to test for the mean, it would have to be a normal distribution because the mean and the median are the same. But if you have a normal distribution, you do the two sample t-test
Exactly.
because you have more power with that.
If they have the same shape, and that shape happens to be normal, then these two are the same thing. Okay? Number 10 talks about unlogged forests and logged forests. Are those independent samples or paired samples? They're independent, so to do a non-parametric test, which one would you do?
The rank sum.
Rank sum.
The rank sum test, that's right. So I did the rank sum test by using the logged, I used the unlogged forest. Most of you did the logged one, which after I did my key, then I thought, yeah, that probably would have been smarter because there's one less thing you got to sum up. But remember, it doesn't matter. So what I'm going to write here assumes using the unlogged forest. But the first step is to, or we got 9 numbers. So put them in order and then rank them.
Because I got a question on this one. Even though we're still doing a one-tailed test, we're still testing the distribution though because it doesn't say that we can assume that it is normal or that it has
The same shape. Right. But it does say reduce the number. Right? So it's just a shift in that distribution. Right?
Okay.
So the difference in the distributions is that one is below the other. But recognizing the confusion there, but I copied this one straight out of the book. And that's the way they worded it. And I thought the same thing. Well, reduce, but really only testing do they have the same distribution. But the way they say it in the book is the null is they have the same distribution, and if you reduce the number, that means that whole distribution shifted down. So I only took 1 point off if you made it into a two-tailed test. But so what I have for the null is the distributions, and I just wrote it out. Distributions are the same, and then I wrote logging changes the distribution of species, shifting it to the left. That's not shifting.
It's a lot to get from the word reduce. That's a lot to get from the word reduced.
Yeah. But, I mean, that's all you can say. You know, you can't say the medians are the same or different, but.
So just in general, I just want to make sure. So even though if we, I guess, how do you know, like, if it's what you're rejecting then? Because let's say it's not significant, why are you saying that it didn't shift to the left, or are you saying the distribution isn't the same?
If you do the one-tailed test, then you're saying, well, the alternative didn't happen. It did not shift it to the left.
Okay.
If it changed the distribution somehow, but the location of the distribution stayed the same, then technically that's not the null, but it's not what you're interested in either. So that's a subtle problem with these non-parametric tests, is that. But most people just say, is there a difference between logged and unlogged? Yes or no. Right? I mean, that's the way it's used. To write it mathematically precise becomes a little bit of a challenge. Okay, so now writing these things all in order, smallest one is a 4, then a 10, then 2 13s, a 14, 2 15s, 18, and a 20. And then rank them. 1, 2, 3, and 4 would average to 3.5. 14 gets a rank 5. 15 gets 6 and 7. Oops. So you average 6 and 7 to get 6.5. And then 8 and 9. I don't remember if anybody made this mistake, but a common mistake is to say, okay, these are 3.5, and then when you start on the next one, you put a 4, because this one's in the 3s, so the next one's, but you have to go to what it would have been if these weren't tied. Right? That's the 5th smallest number. And then I circled the ones that came from the logged, or the unlogged, which are these two, and then one of the 15s, and then the 18 and the 19. And I summed those, and I got W equal 30.5. 30.5. So if you sum the ones that aren't circled instead, which a lot of you did, you get 1 plus 2 is 3, 8, 14 and a half. Right? So I'll say, or you could get 14.5. And what it turns out is that the expected value, since they aren't the same sample sizes, one has 5, one has 4, the mean expected value of W is a little bit different between the two, but each of these is the same distance from their expected value. One is above it, one is below. So I'll just finish out. There was some confusion about these formulas. People were mixing up the signed rank formulas with the Wilcoxon rank sum formulas. So for me, I used the first group I called unlogged as group 1. So that's N1 times capital N plus 1 divided by 2. And there were several of you that had no subscripts, just had capital N times capital N plus 1 divided by 4, which is in the ballpark but not quite the same, because it would be the same if they were equal sample sizes, but they're not. Question?
I thought it was N1 times N2 times N capital N plus 1.
That's for the standard deviation.
I thought that was for if the groups were different sizes, that's how you solved it.
No, for the expected value of this test statistic, it's whichever group you summed. How big is that group?
Gotcha.
Right? But the variance has both groups in it. Yeah.
How come you don't add the into capital N plus 1 divided by 2 since the sample sizes are different?
Because that's going to give you the total. Because I looked at that.
Yeah, I remember that you did that actually. What that does is gives you the sum of the first 9 integers. What I want is the sum of 5 of those 9. What would I expect that to be if they were equally distributed? So you added plus into, right? And if you add those two numbers together, you get the sum of the first 9 integers. You get the same number. Right? So this just tells us how much of that total sum should be appropriated to the first group, if the null is true. Right? And so the number that I got here is 25, which would be 5 times 10 divided by 2. So 50 over 2. What do you get if you sum the other group? I forget what it is. I didn't write it. 20? So you could say, or 20 if you use the log. Right? And then sigma sub w is the square root, and this one has both groups in it, so you get the same answer whichever one you did. But it's n1 times n2 times cap n plus 1 all divided by 12. And plugging all that in, you get 4.0825. Okay, now this says to do the test without a continuity correction, so then the z, you don't need to move your, your w a half a unit closer to the expected value when you don't do the continuity correction. The next problem has you do it. But so for mine, that's just 30.5 minus 25. So the observed value of w minus the expected value of w all over sigma w, 4.0825. And that is 1.347. And what's the distribution of this? Hint, we called it z. It's standard normal. So this is 1.3 standard errors away from the null, which is not particularly far. It's not statistically significant. How do you get the p-value from that?
Normal CDF.
Okay, so the p-value is normal CDF from, mine is a positive, so I'm going to go from that number up to infinity. So I'm just going to write z up to a bunch of 9s, and then 0, 1. If you used the other group, you would have got a negative z. Now what's your value of that z? What's that?
Oh, you're talking plugging it in, or what's the value?
If you'd used the other group and got a rank sum of 14.5, you'd have 14.5 minus 20.
Yeah, it should be the same.
It should be the same number, but it'll be negative. So you go negative infinity, negative 9999 up to z instead of z up. And there were a couple people that got into the wrong tail there, right? So it happened when this was negative. They still went from z, which was negative 1.347, up to positive infinity, so you get 1 minus what the p-value is. Now, since this is a one-tailed test, you don't have to remember to multiply this by 2. But if it were a two-tailed test, then you just take that answer times 2 and you'd have it. So state your conclusion. Oh, I didn't write down what the actual value of this was. 0.089.
Can't reject.
So
Don't reject.
it's kind of borderline, but you don't have enough evidence to reject the null hypothesis. So you cannot conclude that logging changes the distribution and shifts it to the left.
Man, what else people worry about?
Yeah. And you got to look at this anytime you get data like this where you've got 4 observations or a few observations, you have to think, yeah, you'd have to have a pretty dramatic difference to be able to detect it on that few of observations. So I would not, based on this p-value, off of a sample of 9 forests, I would not conclude, don't worry about it. There's no issue. I would say, we need more data. Type 2 error, possibly. Yeah.
Also, I'm not sure there's a relevance between saying, oh, because you've logged the forest, there's less species available, because trees compete for sunlight against a lot of those other species. So you could have, a lot of other species coming in because the trees aren't soaking up the sunlight. So I mean, the whole premise of this is kind of suspect.
No, it's actually, this is based on real data. This happens. If you log the forest, it takes a while for the diversity of species to come back. That's the point. So you're right about those things, but it takes a while for the diversity to take. There's a few species that get in there quick, and I mean, we learned it in middle school, the succession of the forest, right? So cedar trees in Kansas come up first, but then other trees grow and they shade them out, and the cedar trees die off.
Sounds like a design and experiment issue.
Yeah, and it is. That's exactly right. Okay, so that's not what we're here to debate.
We're here to debate statistics.
That's right. So this one, trying to think of what the common mistakes were on this one. It went pretty well, actually. This is one of those cases where you have to work the problem to show that you know how to work the problem. But if I were a statistician and somebody presented me this data, I could look at it and go, nope, you don't have any difference, right? Because what do you see in the data? You got 5 observations, 3 of them are negative, 2 of them are positive. That's about half and half, right? So it doesn't seem that there's any pattern of, yeah, they always go up, or yeah, they always go down. So almost certainly, without working it, you could say there's not a significant difference between the 2 types of stories, or whether you show it with pictures or not. But to do it, what is the null and alternative hypotheses?
That the 2 stories I said have the same distribution.
Yeah, that's about all you can say. The 2 stories have the same distribution, so I'm just going to abbreviate same distribution.
And the opposite of that.
And then the distributions are different. So, different. And I went ahead and told you, I wrote it out this way, and I thought, well, maybe I should change that and not tell them what kind of test to do, but I went ahead and left that in there. So I'm not usually that nice that I say, do the Wilcoxon sign range test.
You notice what you actually wrote there?
Rank sum.
Oh, I did, didn't I? Yeah, and you know how that happened? That shouldn't be there. That happened because cutting and pasting from other, old tests and stuff, I decided, well, I'm going to switch it instead of doing a rank sum. So then when I copied and pasted, I didn't catch that word in there. So, this time I'm worried about time again. It turns out I was more worried about time than I needed to be, because you guys all got done fairly quick. And some people took the whole time. But nobody took till 3, like sometimes happens. So I told you that W is, or I put the plus in the wrong spot. W plus is 9. And so then you need to compute the test statistic and run or get the p-value. So the expected value of W plus. Now you don't have an N1, N2. You've got 2 different types of stories, but then you take the differences within those and you reduce it to 1 sample of differences. So now it's just N, lowercase n, is the number of pairs, or the number of differences. Right, so the expected value is n times n plus 1 over 4. Yep, so that's 7.5. The sigma sub w, if the null is true, then you would expect n times n plus 1 times 2n plus 1 all over 24 for the variability. And that's 3.7081. Now we form our test statistic, and we're supposed to use a continuity correction. So 9 is bigger than the null value, right? The expected value of W is always computed if the null is true. So if the null is true, we expect 7.5. We are a 9. So what number do I use? Do I use 9.5 or 8.5? 8.5. And those of you that had 9.5, because there were a few, now no, because I would have marked it on there. But why do you go closer to the null? That's how you remember. You always go closer to the null.
Because how intervals work? I mean, because what you're doing is you're doing a left, you're doing a right. I'm not to draw it out, but
Yeah, let me draw it out. Let me draw it. I think it's worth talking about because people are still getting that confused. If I have, that's probably not dark enough. If I have a discrete distribution, then it's going to have bars, right? And those bars are of width what? 1. So p-value, by definition, p-value is the probability of getting value like you got, or even further from the null. So the null's in the middle at 0 or 7.5, whatever it is. And we got 9. Well, 9 would be the middle of that bar, right? So by definition of a p-value, if this was a continuous distribution, I would draw a dotted line above the 9, and I would shade in the tail past that. But since it's discrete, I need to get this whole bar. So I need to go a half a unit back to get that whole bar so I can shade that bar and then this bar and so on. Right? So you take 9 minus 0.5 since 9 is above the null value. If you were in this tail, you'd be shading the other way. So you'd add the 0.5 to get closer to the null. Right? So that, I can never remember, do I add or do I subtract? And the answer is, depends. You just go closer to the middle. Half a unit closer to the middle. Okay, so I'm going to take 8.5 minus 7.5. I'll do that one in my head. Divide that by 3.7081.
do that in your head.
I can, I just don't like to show off.
0.26968.
0.26968, is that what you said?
Yep.
Okay. Now that's a z value, right? That's number of standard errors. That's not big, is it? Right? That's not a p-value. Sometimes people get all p-value happy, and if they get a number somewhere along the way that is between 0 and 1, they think, oh, that's my p-value. But we're not to the p-value yet. So we're going to get a really big p-value for this one. So this time it is a two-tailed test. So the p-value is 2 times the normal CDF from that number up to positive infinity. 26968 up to a bunch of 9s, 0, 1. And what I got for an answer is 0.7874. Okay. Your answer might be slightly different than that because you use different amounts of rounding on things, and that's fine. if you didn't do the continuity correction, this would have been 9, so you'd have gotten 1.5 in the top. You'd get a fairly different number. It's not going to change the conclusion any because it's not borderline, but you'd have a fairly different p-value. So the conclusion, since that's a big p-value, then it's pretty likely that the null is true, so you don't reject it. There's not enough evidence from this data to say that there's any difference in the scores when they are shown pictures while reading versus not. Okay, I just realized I'm starting to run out of time here, so on this last page is the Chapter 17 stuff. I won't go through number 12. I think everybody got that right. There weren't very many that missed it. There were a few that missed here, different mistakes, but the way this is done, mark all X points considered out of control. You got 2 rules, 9 in a row or outside the limits. So clearly, these 2 up here are outside the limits, so they get X'd. But then you find the first one that's above the mean, that's this one. Do I have a undo button? Yeah. So that's the first one, 2, 3, 4, 5, 6, 7, 8, 9. So there's the first one for the 9 in a row rule, and then there's another one right there. So there should be 4 points marked. Okay.
That just cleared everything.
I guess that's what I wanted. Now, the last problem, give the center line and control limits for an S chart. What's the center line for an S chart?
S bar.
Just S bar. There were a few people that gave me sigma hat there. And remember, sigma hat is, how do you get sigma hat?
S bar divided by C4.
S bar over C4. So some people gave me the center line as S bar times C4. Well, if I multiply through by C4, C4 times sigma hat is S bar, and I think there was confusion about how that all worked. And then the lower limit and the upper limit are multiples of sigma hat, not S bar. So that was a mistake that a few people made. They used S bar down there instead of sigma hat. But this should be, the lower limit is B5 times sigma hat, where sigma hat is that. And then this one's just B6 times sigma hat, which is 0. The lower limit is 0 because B5 is 0 if you look down in this table. The upper limit is 2.28. 281 if you go out there. And then center line and control limits for X bar chart. So the center line is just X bar bar. That's the number given to you. And then lower limit is X bar bar minus 3 times. And there's another mistake, and it's a common mistake. It's sigma hat, not S bar. So it's sigma hat over the square root of n. And then upper limit is the same thing with the plus. Okay? So this thing, S bar over C4, is what goes in there for sigma hat. So you got a good share of partial credit if that was your only mistake or whatever, but not full credit. Okay, out of time, so we will we'll look forward to your presentations on Wednesday. Make them good. See you then.